When working with React, it's important to be aware of the concept of immutability and immutable state. Immutability means that data is not modified directly. Instead, new data is derived from existing data and may replace the existing data. If there are arrays or objects in the state, we could try and mutate them directly. However, don't do this. React will not notice the changes and may not re-render the view. State in React should be considered as immutable or unchangeable. Why does React not notice the state changes if we mutate objects? Well, when a state setter is called, React will compare references, the old state reference and the new state reference. If they are the same, the component will not re-render. As a real-life example, we could imagine arrays and objects as containers or boxes that hold other elements. Now, if React receives such a container for the first time, it will pass it on to the renderer to create a rendering based on its contents. If I would then change the contents, but pass the same object to React again, it would basically say, I've seen this state object before and already done a rendering based on it. There's no need to re-render again. Even though the contents of the object are actually different now, React will not re-render. We can see this as an example here. The state of this application contains an array. And there are two different buttons that are intended for adding elements to the array. In the implementation, we see that the action of the first button will create a new array for the state, based on the old contents, and also including one additional entry. This action will not modify the old state and will therefore work correctly. We will talk about the meaning of these three dots in JavaScript in more depth shortly. On the other hand, the second button does modify the content of the array by calling .push. Therefore, no re-rendering will be triggered. So as we can see, the first button works as intended, but the second, which mutates the entries, does not work. So we've seen that in order to work with objects and arrays in React State, we need to manage them without modifying them directly. In general, in programming, there are two options for getting updated data from previous data: mutating the original data or creating new derived data from the original data. In React, we should always use the second option. We will now take a closer look at how we can achieve these data updates in JavaScript without mutations. We will see how to add properties to an object, how to change individual properties of an object, how to add elements to an array, how to change elements in an array, and how to remove elements from an array. Mechanisms that we will use will be the so-called spread syntax and special array methods, in particular .map and .filter. Here we see how we can use the spread syntax for managing arrays. In this example, new elements get added to the end of an existing array. In the beginning, the contents of an existing array, called numbers in this case, are unpacked and put into this new array one by one. We can also use this spread syntax for objects. In the case of objects, we can use it to add new entries or to overwrite pre-existing entries. In the example, we use the original person object as the basis, but we add an entry named email and we update the entry named age. In general, entries that appear later in the code overwrite earlier entries of the same name. The map method can be used to create a new array based on the existing array, where each entry of the new array corresponds to an entry of the old array. The transformation that transforms an old entry into a new entry is specified via a function. In the first code example here, the transformation function is specified as an arrow function. The second example makes use of the built-in square root function. The filter method can be used to filter out some elements and only keep certain elements in the resulting array. For specifying the criterion for inclusion in the array, a function can be provided. The function will receive an element and return either true or false, which will determine whether the element will be included in the result. In the example here, we provide an arrow function that tests whether a value is even or not. So to sum up, we've seen these mechanisms. For managing objects, we can use the spread syntax, both for adding and for changing properties. When dealing with arrays, we can add elements by using the spread syntax, we can change elements by using map, and we can remove elements by using filter. Now let's do some exercises on the topic of immutable data. We'll be managing to-do data without mutations. I've prepared a code sandbox as a starting point. The link will be in the video description. The task here is to finish some pure functions in the code on the left. We can check the results on the right. The first task would be to finish the implementation of a function named changeTitle. This function is supposed to change the title of a to-do, but not by mutating an object. It is supposed to return a new to-do without modifying the original. On the right-hand side, we see that at the moment, this function does not return anything. And I'd like to change that now by finishing the implementation here. I would suggest pausing this video right now and trying this on your own. Alright, let's implement the solution here. I could start off by just writing return to-do. Of course, this would return the to-do unchanged, as we can see on the right. In order to actually modify entries, what I could do is create a new element and then unpack the existing to-do object into that element. And during unpacking, I could also overwrite one entry. I would like to overwrite the title entry with the new title parameter that was passed in. And the solution seems to be working out well here. I'm passing in bar as the new title, and it will actually be applied to this to-do element. Next up, I want to finish the implementation of this function named addTodo, which should process an array of to-dos and add one more to-do to it. On the right, I see an array of original to-dos, and I see that at the moment addTodo does not return anything. Again, pause the video to implement this by yourself. I'll show you one possible finished implementation of the addTodo function. The code that is already in here provides me with either the current maximum ID or 0 if there are no to-dos yet. And I can use that to create a new unique ID. I'll start off with return, and I would like to return an array that contains all the previous to-dos and then one more. And I'll do that via using the spread syntax here, and then just adding one more item in here. The title will be the title parameter that was passed in, and completed will be false for a newly created to-do. Again, on the right-hand side, I can check the output, and I see that there are 4 to-dos where there were 3 before. Now, I want a function that removes the to-do based on its ID. Again, pause to implement this yourself. Whether I want to remove one element or multiple elements, filter is the way to go. So I'll start off with return todos.filter. And here I can specify a criterion via using a function. I'm going to put an arrow function in here, and that arrow function will receive each element of the array and decide whether that element can stay in by returning true, or whether that element should be kicked out by returning false. I'm going to call that element to-do. And the criterion I can use here is if todo.id is different from the specified ID, then it can stay in. Only the one to-do where the ID matches will not be allowed to stay in the new array. Let's check the result here. So apparently removeTodo actually removed the to-do with the ID number 1, so it's working correctly. Finally, I want to create a function that can set the completed status of a to-do based on the to-do's ID. We've previously created a new entry in an array via the spread operator. We've deleted an entry in an array via filter. Now we can update one or more existing entries via map. Pause now to do the exercise yourself. Here I will start off with return todos.map, and then I can specify what should happen to every entry in the array. And I can do that via providing a function that can potentially transform an existing array entry. The parameter here I'm going to call todo, and then I can decide whether I want to modify something or whether that to-do can be unchanged. If the ID of the to-do actually matches the ID that was passed in, I want to change something in the to-do, and otherwise I want to do nothing. Doing nothing in this case means returning the to-do unchanged. And actually changing something would mean returning a new object. In this new object, I'm going to take the previous to-do and overwrite one entry. The entry is called completed, and I'm going to overwrite it with the parameter that was passed in, which is also called completed. So in the end, this is what our new array looks like, and the completed entry has actually been changed to true. Here are some more exercises that you can try. The first exercise would be to update the newsletter sign-up from the last video to use one state object instead of 3 separate state entries. Here's what that state declaration could look like. For the second exercise, you can write some more pure functions that handle to-dos. If you want to share your solutions or you have questions, leave a comment on this video.